Hi everyone, welcome back to Mr. Carroll's classroom. Today we're going to solve systems of three equations with three variables, so let's check it out. Okay, so similarly with two equations, two variables, we have four different ways to solve these types of systems. The first method is going to be graphing. All right, the second method is going to be substitution, third elimination, and fourth will be with matrices, which is definitely the preferred method. However, you can only it's only beneficial, I should say, to use matrices if you have a calculator or a computer. You could technically do it by hand with matrices, but that would defeat the whole purpose. But anyway, so the most important thing if you're stepping up from the system of two equations, two variables, up to three equations, three variables, is you need to keep your head on straight. There are going to be a lot of different combinations, and you really should follow the appropriate steps. And the big recommendation I give for students is find a method you like and practice it, so that way you can ensure that you never end up going around in circles, because that can happen very easily. Okay, so let's talk about graphing first, because graphing for Algebra 2 students is probably not going to happen because of the way that these look in in three-dimensional space. With two equations, two variables in two-dimensional space, you're just talking about two lines, and you guys have a lot of practice at that. But three equations, three variables, what do those actually look like? Well, let's check it out. Okay, so here I have a graph, and these represents three different equations, all right, a system of equations. And so what you can actually see here is that these three equations graphically represent planes. So they're not actually these little boxes that you're seeing right here. They go on forever. So they are called a plane. And these three planes happen to be parallel to each other. So just like with any system, we're looking for solutions where these things would intersect each other. Okay, where they intersect each other, all intersect each other, that's where our solutions will lie. So for example, if all of these three planes ended up being the same plane, then we'd have infinite solutions. But if two are the same plane and one is slightly off from the others, then it doesn't satisfy all three, so there are no solutions. Okay, here's another example. There are quite a few different ways that these could be oriented, but here are three planes, all right? And in this case, all three intersect, but there's nothing in common, right? If I say, well, these two intersect at this line right here, well, any point on this line does not touch this plane over here. So it has to intersect all three, all right? So what are we really looking for? Well, we're looking for a graph that looks like this, or something similar to this, right? Where all three are going to intersect somewhere, in this case at this point right inside of here, okay? So that's really what we're looking for. There are actually, I believe there are 8 different combinations for how, the general cases, I should say, for how these planes can interact with each other or intersect each other, or whatever shape I guess you want to call it. I guess I'll leave it up to you to decide what those are. I just gave you 3 of them, and you can kind of play around and see what the other general ways that these things can form or relate to each other are. So, all right. Anyways, okay. So let's go back now to our drawing. Okay, so again, graphing, where it's pretty much, we're not going to be able to do that by hand at this level anyways. But anyway, so let's go to substitution. So if you're solving these by hand, you're going to use substitution or elimination. Both of them are a little bit lengthy processes. Personally, I prefer elimination, but both of them really involve just a process that you really just have to practice, okay, in order to get good at. So let's go ahead and I'm going to go through these one by one now, okay? All right, so substitution, we're going to start here. All right, so I'm going to bring an example up. So here's an example of a system of 3 equations with 3 variables, and this has a really nice order to it. It doesn't, like, your problem may not have a nice order at the beginning, but you can use a little bit of algebraic manipulation to get all of the x's to line up, y's to line up, z's to line up, and these constants to line up as well. Okay, that's usually our starting points. Get them all lined up. Okay, and sometimes when you do get them all lined up, maybe this 6x and 3y don't even exist. Maybe it's just z is equal to negative 45. Well, congratulations, you have one of the solutions, and then you would just plug that into the other two and go ahead and continue solving. But that's not the case here. Okay, so what are the steps for solving a system of three equations with three variables using substitution? All right, well, let's bring up the steps. The first thing I like to do is I label my equations, 1, 2, and 3. That way I always know where I'm at. I promise you, this is like a puzzle, and you can definitely get lost very quickly. All right, so let's cover these steps. Step 1 is solve the first equation for z. Technically speaking, you could use any variable, but we're just going to say solve the first equation for z. All right, and personally, the one I would use is the one that maybe has a coefficient of 1. All right, but anyway. Step 2 is going to be substitute the expression for z that you came up with into the second equation. Okay, so once you substitute in for z, you've essentially gotten rid of z. So you should have one equation with two variables now. You've eliminated one variable. Then step 3 is going to be use substitution to solve for x, for that one of the two variables. All right, in this case, x or y. And then step 4 is going to be substitute back up the line, okay? Okay, so let's get started here. Step 1, solve the first equation for z. And I'm going to color code these here. So here we go. First equation, if I solve for z, I get z is equal to negative 2x minus 7y minus 53. Let's go to step 2. Step 2 is going to be to substitute that expression into the second equation for z, essentially getting rid of the z and just having x and y's. So let's go ahead and do that. So if I plug in the expression for z right here and then simplify this, then I should end up with one equation with two variables. Y is equal to negative x minus 10 in this case. Let's see here. Next step. I actually I solved for y here instead of x. Again, the step said solve for x, but that's okay. It doesn't really matter. Okay. So now what we're gonna do is we're gonna take both of these. All right. We're gonna take this y. Y is equal to negative x minus 10, and we're gonna substitute this back into I'm sorry, not back into, but down into the third equation. Okay. One of the biggest things that you can do to not run around in circles is make sure that you use different combinations of your equations. I used 1, 2, then 3. All right, so take a look. If I look at the third equation, I have three variables, x, y, and z. However, I have for the y, I have y in terms of x right here. Y is equal to negative x minus 10. I also have this expression here for z that I'm going to go ahead and plug in for z, this blue one, which has an x, and I want that x, but it also has a y. I don't want that y. So I can get rid of that in terms of x as well. Right here, I have this y is, again, negative x minus 10. So I'm going to plug that in for that expression. So I'm combining everything, all of the work that I did into the third equation to get one giant equation with one variable. Notice there is only an x in here. Okay? So then I solve for x. So x is equal to negative 4. At this point, all the hard work is done. Now I just go back up the line. Okay, next step is going to be to take that x is equal to negative 4, and I'm going to plug it back into this equation right here. Y is equal to negative x minus 10, because now I can solve for y, as I did right here. So I get y is equal to negative 6. And now that I have x is negative 4 and y is negative 6, I can go back up to the original right here. I shouldn't say the original expression or where I solve for z, where I can plug in x and y and get my value for z, which z ends up being negative 3. All right, that's not my final answer. I need to list my final answer appropriately as an ordered triplet, in this case, x, y, and z. Because what does this point represent? Well, it represents a point in 3 space. So there we go. That's how we use substitution to solve a system of 3 equations with 3 variables. All right, that is not my preferred method. That doesn't mean it's any worse than elimination. I just happen to use elimination most of the time. So let's go ahead and we will bring up elimination. All right, so let's bring our problem up. Here we go. We have another system of equations with three variables, x, y, and z. And there's nothing saying this process is any shorter than the other one. Again, it's just a different process that I happen to use most of the time if I have to solve by hand, which hopefully I don't. Then I would use matrices. But let's go ahead and bring up our steps to solve this. So first step, of course, is always number your equations. It's very, very important here to number your equations so you don't repeat combinations. And let's cover the steps to solve. So to solve using elimination, we're going to combine two equations. You can pick any two that you want. And then we're going to eliminate a variable. Okay, so you're going to want to look at these and take a look and see what eliminates nicely. Like, for example, right away I can see in the first two equations, if I add the first two up, then the x's are going to be eliminated. Okay, something I note right away. Of course, if nothing is easily eliminated, you can manipulate these using algebra, multiply by -1 or -2 or +3, whatever it takes to get these variables to eliminate. But anyway, so we're going to combine two equations to eliminate a variable. Step 2 is going to be combine two different, very important, different equations to eliminate the same variable. Why? Well, if we're eliminating the same variable, then we should end up with two different equations with only with two of the same variables. And that way we are basically knocking this from a 3-equation system down to a 2-equation system of 2 variables, and we can solve that easily. All right. After that, once we have once we have the two equations with 2 variables, we're going to go ahead and solve that, which we should have plenty of practice with. And then finally, once we've solved for those 2 variables, we just simply substitute into any of the original 3 equations to get our 3rd variable. So let's go ahead and get started to see what this looks like. All right, so step 1 is going to be combine 2 equations. So in this case, I combined equation 1 and 2 because the x's will cancel. I don't have to change these at all. I don't have to do any algebraic manipulation. So once I add these up, then I get 2y plus z is equal to 10. All right, next step, step 2, is combine 2 different equations to eliminate the same variable. All right, now this one's not quite as easy. What I'm going to end up doing is combining 2 and 3. Remember, it has to be different equations. And what I'm going to do is I'm going to multiply the bottom, the 3rd equation, by 2. So that way I can get my x's to cancel. The most important things are that they are 2 different equations or a combination of different equations, and we need to eliminate the same variable. Okay, so here we go. So I took the 2nd and the 3rd and I multiplied the 3rd equation by 2. So I got 2x plus 4y plus 2z is equal to 22 after I multiplied. Now I'm going to go ahead and add these 2 equations up because my x's are eliminated. Again, it's important that you eliminate the same variable. And now you can see here I have 2 equations. The first one has variables y and z, and the second one has variables y and z as well. So I essentially came up with a new system, right, with those two equations, 2 variables. So let's go ahead and solve that. All right, you can use any method you want here. I chose to use substitution in this case, where I solved for z, and then I plugged in that expression into the other equation and solved for y. And you can see the math there. You can pause it if you want to check it out. And then once I have y, I'm going to go ahead and plug z back into any of these original expressions. I'm going to plug it back into this one right here since z is already isolated, getting z is equal to 2. And there we go. So I have 2 of the solutions already. So y is equal to 4, z is equal to 2. Now I simply have to plug in those 2 numbers into any of the originals, and I can solve then for x in this case. So let's go ahead and do that. So I'm going to go ahead and plug it into the bottom one since this has smaller coefficients, and I will go ahead and solve for x. Now again, this isn't how we list our answer. The answer here, because since these are 3 planes that are all intersecting each other, they all intersect at one point, and so we call that an ordered triple. not an ordered pair. That would be two-dimensional. This is 3D, so this is an ordered triple, getting our value, our point at 1, 4, 2. All right, so there you go. Those are how the two examples using substitution and elimination in order to solve a system of three equations with three variables. All right, I'm not going to stop here. Even though I will have an entire lesson dedicated to using matrices, I do want to, whoops, hang on one second. Let me get rid of my work. There we go. I do want to show you matrices, okay? So let's take the exact same problem here. So I'm going to take the exact same problem and list it up here, and I'm going to show you how the steps, at least the steps in order to solve this using matrices. I'm not going to go over why or how or why I'm doing it. That's for the other lesson, but I just want to show you how easy it is. So step one, once this is all lined up vertically with the x's, y's, z's, and the coefficients, we are going to transform this thing into a matrix equation, putting all of our coefficients right into this coefficient matrix. So you can see all these line up, 2, -2, and 1 for the x's, 1, 1, and 2 for the y's, and -1, 2, and 1 for the z's. Then we have our variable matrix, which is just in order x, y, and z. And then we have our constant matrix, which is the 4, 6, and the 11. Now, in order to isolate the variables, I need to get this matrix over to the other side. I'm not going to explain why I'm doing that, but I'm multiplying both sides by the inverse since there's no division with matrices. But you can multiply by the inverse to eliminate things to give the same exact effect. So I end up with this XYZ matrix is equal to the inverse of this big thing, this 3 by 3, times this matrix over here. At which point you just you put this in your calculator. Your calculator and computers are amazing at utilizing matrices. But anyway, so once you plug it in your calculator, then it'll just spit out an answer, and you get the exact same answer that we just came up with, 1, 4, and 2, and we would just list it as our ordered pair, and that's it. So yeah, matrices, you can use matrices to solve any system, but you have to have a computer or a calculator in order to do that. Okay, if that would always be my first attempt unless I'm limited in some way. Okay, all right, guys. So I'm going to go ahead and put these back up here. So what we talked about today was how to solve systems of three equations, which is three planes, and we use graphing, which really we can't do without or by hand at this point anyways, but we can use substitution and elimination. They're both processes that require practice. Okay, personally I prefer elimination, but it's really up to you. And then if you do have a computer or calculator, matrices is easily the most effective and efficient way of solving these. So hopefully you got something out of this lesson, and I will see you in the next one. Take it easy.